Now let's take a look at the schematic of the pulse sensor circuit that you'll be using in the laboratory experiment. And at first glance it appears to be complex, but we can break it down into its functional parts. And in the upper right hand corner, this is actually the power supply portion of the circuit. And then over here on the left hand side is the LED and the photodiode circuit. And this portion of the circuit is some filtering, and finally there is an operational amplifier before you get to the output. To close out the bioelectricity module, let's talk briefly about electrical models and systems level representations. So the focus here is on models. And in this context, when we refer to an electrical model, we're referring to a mathematical representation of a device, a component, or a process. And we can have very low-level models, or we can have very high-level models. And in this diagram of the pulse sensor circuit, the resistor, for example, and the capacitor are low-level models. And if we're talking about a resistor, then the mathematical model is simply the ratio of the voltage to current across the device, which of course is equal to resistance of that part. On the other hand, if we look at the operational amplifier, this is a high-level model, and this will give the right transfer function, which is actually a fairly complex mathematical representation, depending on the applied DC voltage. But if you were to look inside this high-level model for the operational amplifier into a lower-level model, you'd have something that's made up of many transistors and resistors and capacitors, as shown here. And you could even look at this entire model of the pulse sensor circuit here. This all could be represented as a single box that would have a power supply pin, a ground, and then V sub out. So this would be a very high level, very simple model, but of course buried within that model would be all the smaller parts that you see here. So this concludes the ENFUSE module on bioelectricity.